Let's get started. Thanks for joining. Thanks for joining our webinar, the first in a year. I'm happy to share it together with our partner from Climate in person here with Lybo Mianchev, the CEO of the company. So we are going to tell you a few words about monitoring of electrical power via LoRaWAN. And there, Climate has two very nice new products that we are going to have a deeper look into them. But before, let me briefly start. What is the agenda for today? So I will have a short introduction to who is MTM Germany, of course, and then my part will be to speak about LoRaWAN, some general introduction to the topic. However, I have the feeling from the people that I can see here that most of you are pretty much aware of what is LoRaWAN and how it's working, but nevertheless, maybe there's some new people to LoRaWAN, so I'll say a few words about that. And after that, I will already hand over to Lybo to give you an introduction about Climate and then having a deep dive into the new products and the applications around them. So that is what we're going to do today. First of all, who am I? Who are we? Who is MTM Germany? My name is Maras Nikolai. I'm one of the two CEOs in the company, together with my partner Ralf Schuler. And MTM Germany is a specialist in wireless technologies. So that means we are working with different kinds of technology, not only LoRaWAN. And we are a distributor, which means we resell basically the devices of some of our partners, like Climate here in the market. But that's not the only thing we are doing. So we take care on bringing you some knowledge, and so it all starts with the consulting, which is the right technology, which is the right product for your application. We also help you to set up the whole environment, which in terms of LoRaWAN can mean the LoRaWAN network server, base stations, etc. So we're going to talk a bit more about that in a few slides. Our company is actually turning 18 this year, so we have been founded in 2007. And we are based here close to Frankfurt, right in the middle of Germany, and are currently 25 employees. So what does that mean, what we are doing? As I said, we are expert for wireless connectivity, which means different kinds of technology that you can find here in the middle of the slide, like LoRaWAN, but also 4G, 5G, Bluetooth, narrowband IoT, these kind of things. So let's say international standards for data transmission in industrial applications, basically. We are doing that in many different market segments, branches. So we don't really have a focus on that. Our focus is on the technology, which can be used in many different applications. And so we don't care if it's a kind of machinery, some PLC, or any kind of different application, vehicle, whatever, where we need to raise the data and transmit it via any of these technologies to a third-party application or to some energy management system or some building management system. So this is more or less independent from the application, the technology. Having a look into LoRaWAN, which kind of things we are offering here is, of course, we are supplying the devices like the sensors, the gateways, even the modules for the integration. If you're looking into some own hardware that is using LoRaWAN. But what is even more important is the network, which means you need the LoRaWAN network server. You need to place at least one, or depending on the area, more than one base stations. So you have to consider where to place the base stations, to set up your network and reach all the devices in all the locations that you want to reach, where you have to place the sensors. So that is what we are helping our customers with as well. So, but that should be enough enough about our company, and I'm telling you a few words about the technology itself. So, just to get a rough idea, what is LoRaWAN? I made this graphics here where you can see different kind of technologies compared to each other in terms of the possible data rate and the range of the technology. Of course, it's just a rough to get a rough idea. So it's not really precise, but in the corner here on the right side, down on the right side, we have all this kind of so-called LPWAN, low power wide area network technologies, where also LoRaWAN counts into, beside things like Sigfox, for example, or Narrowband IoT, LTE Cat-M in the mobile network operator spectrum. So these kind of technologies are aiming for things like sensor networks with a high range and a low bandwidth, basically also focusing on a low energy consumption. So, and you can already see here, LoRaWAN is meant for distances of some kilometers. So the saying is like 2 to 3 kilometers in urban areas and 10 to 15 kilometers in rural areas, basically. But of course, that is up to the specific area that you want to cover. On the other hand, you can see technologies like Wi-Fi on the upper left corner, which has typically a short range of like 50 to 100 meters. I think everybody knows it from home, so you can cover your flat or your house with Wi-Fi, but not much more. But therefore, the data rate is quite high. You can do any kind of video data streaming, whatever you want, which is completely impossible with LoRaWAN. So in LoRaWAN, we're just talking about sensor data that is, for example, sent every few minutes or just every hour or something. So that is what we're talking about, just to get a rough idea about the technology. So, and the next thing is that we have to that LoRaWAN and LoRa is not the same. So we are starting with LoRa, which is the wireless technology that is used. So that means this is the physical layer, and which is using in the EU the 868 megahertz band. In US, for example, it's 915 megahertz, and basically this LoRaWAN layer is the base of where the LoRaWAN protocol comes on top, which we'll see on the next slide. And using this LoRaWAN technology, we have a very good range. We were just talking about 2 to 15 kilometers. And we have a good penetration also into buildings. The meter is based somewhere in the basement of a building. We have a good penetration into that. And of course, we have very low power consumption, which means that you can have many different kind of sensors that run from battery and have many years of battery lifetime. Like, for example, the Wiki thermostat from mClimate, which is used to control radiators, can run up to several years, up to 5, 6, 7 years on a set of battery. Controlled by LoRaWAN, which is pretty much impossible if you use a thermostat based on Wi-Fi technology or something different. Coming to the LoRaWAN protocol, this is basically the communication protocol that is set up on top of the LoRa physical layer, and that is defined by the so-called LoRa Alliance, which is the kind of industry open industry standard. So basically everybody can become a member in the LoRaWAN Alliance. So if you're interested in the protocol, if you manufacture LoRaWAN devices, or you want to gain deeper knowledge, then you can you can join the LoRaWAN Alliance and work together with the different companies on the standard. So, and that is even one of the most important things that I also want to mention, that LoRaWAN is not just a standard that is here and it is as it is, but it's a living standard because there's many industrial companies working on the standard, improving it. So we have new features being added to the standard from time to time to improve the usability of the standard itself. So that is something I can just tell you. You can check out the LoRaWAN Alliance website from time to time to see what is the which kind of things are going on and how the standard is being further developed. But coming back to the protocol itself, just to give you some rough figures, data rates in LoRaWAN range from 250 bits per second up to 50 kilobits per second. So that is not so much, just to say it, but it's fine for the kind of applications that LoRaWAN is aiming at. So we're talking about sensor data. You don't need to control some to send the data, for example, some temperature or even some electricity, current, power, whatever, every second or I don't know, many times per second. So, but to get the data like every 5 minutes or 10 minutes, that is absolutely fine and works quite well in LoRaWAN. The data rate itself is controlled by the so-called spreading factors. It's not only the data rate that's controlled by it, it also has an effect on the energy consumption of the device, and it's like automatically controlled by the network itself. So that is something you don't have to take care for it. You are not choosing the spreading factor by yourself. The network is doing that, but you can have an effect on that by setting up the network. So it makes sense to have a good, a low spreading factor, so that the device has a high data rate, which means it has a short time on air to send its data, and therefore it needs less power. So it always makes sense to have a good network setup where you're not running on the edge of availability, to call it like that. Because that means that your devices will need more energy to send its data, and therefore you're lowering the battery lifetime. So that is something to take into account when you set up your network. And well, I've mentioned it quite a few times already, but one of the most important points for LoRaWAN, you can just set up your private network. You don't have to rely on any provider like Telecom or Vodafone or whoever. You can set up your own network by just placing a single gateway, and that's it basically. There is gateways in the market that have the LoRaWAN network server included in the device, and that's all you need then to run your own LoRaWAN network. But how does the LoRaWAN network look like? I can explain in a few words in that graphic here. So we do have on one side, on the left side, the end nodes or sensors, actors, or whatever. And then you have, at least one gateway, but can be many, can be up to hundreds in a network. And then the heart of the network is the so-called LoRaWAN network server here in this cloud in the middle. And that is the part that is doing all the magic basically. So that is where the network management happens, where the device management happens, which means you connect each sensor to the LoRaWAN network server. You exchange some keys, and that's it basically. The gateways itself is just more or less stupid packet forwarders. So they just collect the data by LoRaWAN and then send it to the network server where everything happens. One thing you should not mess up is the network server and the application server. So some people mistake that the network server is a kind of application server where you have some dashboarding and analyzing the data and something like that. That's not the case. So from the network server, usually you connect to some kind of third-party application. That can be any kind of cloud platform, or it can be a local management system, building management system, whatsoever. But the network server is really just the network management layer. So that is important to understand. That's not the tool to analyze the data or having dashboards or something like that. That is the part of the application server. To sum it up a little bit, why LoRaWAN is a perfect tool for monitoring electric power, where Hugo will talk a bit more about that topic afterwards. It's really easy for retrofitting. So if we're talking about buildings, it's quite hard to exchange cables or to put new cables, new wires. It's expensive. You need to have workers to you'll have a construction site basically. Have to open the walls, etc. LoRaWAN is just, you can place a gateway, a sensor, and that's it. Your communication is up and running basically. So you don't have this high cost for working in the infrastructure. Also, it's LoRaWAN is not there to replace existing systems. So, I mean, if you have some electrical installation in the building, or you already have some building management system, LoRaWAN is not aiming to replace this, but to extend it with new features. So, for example, if you have some LoRaWAN, some building management system that is running on BACnet, you can easily attach a LoRaWAN gateway to it, and you just get some additional data from a LoRaWAN sensor that you then feed into your BACnet system, for example. So it's just a complement. It's not a replacement of existing technologies. And one of the main things is, once you have a LoRaWAN network up and running for a specific use case, of course, it's open to add new ones. So if you're starting to control some energy, like we'll see here with the devices, you add some energy meters, or you want to switch some electrical appliances on and off, you can easily add other use cases. For example, controlling air quality in rooms, measuring CO2 level in rooms, whatever, measuring temperatures, or any kind of other use case can easily be added through LoRaWAN, because there's so many different kinds of devices available. And well, LoRaWAN is basically LoRaWAN, so any LoRaWAN compliant device can be used in any LoRaWAN network. So, said that, I will already hand over to Libo, and yeah, he will go a bit deeper into technology.
Thank you, Marius. I'm gonna share my screen. And first, I'm gonna tell you a little bit about the company itself, and then we're gonna go to the devices. But mClimate, I founded the company 10 years ago, and we started a company with a mission to essentially help decarbonize buildings. It was a mix at the time of, if people were looking for savings or for comfort. But 10 years later, we know that the most important thing is to kind of create tools to give in the hands of our partners, so we can help them decarbonize buildings in different ways, of course. But yeah, 10 years old. We're not so many people. We're about 30 people in the back office, where we have the R&D and logistics, sales, and then we're employing, it depends, but anywhere between 50 to 250 at a time people in the production facility. And yeah, I mean, one of the important things about us is that we're essentially publishing or creating all of our devices with open protocol, which is kind of a standard in the LoRaWAN world. But I want to underline this because we also have some software products. But I want to say, if you're using our hardware products, you don't have to use our software products. That's all. Now, just briefly explanation about the portfolio we currently have. We have divided it in 4 sections. So the first one is indoor climate optimization, where we have Wiki. As Mario said, Wiki is a LoRaWAN radiator thermostat. Depending on the spreading factor that you have your system running on, which depends on the amount of gateways. And we always advise putting at least 2 gateways, for redundancy purposes. If one goes offline or somebody, unplugs it, the other one at least stays online. But it can work for up to 10 years on standard AA batteries. And it's really smart because it has a display, as you can see in the picture. You can rotate the outer part, so you can adjust the target temperature, but it measures temperature, humidity, and it controls essentially the flow of hot water or whatever liquid is inside the radiators, so that it maintains whatever you have set on the display. So it was actually one of our first LoRaWAN devices. And, it's one thing to make only sensors, because sensors are quite easier to create and to manage, but actuators, things that are controlling, things are, harder. And usually you get better ROI if you're also controlling something, not only, measuring things. The second product we have is the HD LoRaWAN. HD comes from humidity and temperature. So it's a super simple humidity and temperature sensor. Sends the data every 10 minutes by default, but you can make it an hour or 1 minute if you wish. But again, all the default settings at 10 minutes, it survives 10 years on battery life. Then we get into something a little bit more exciting, because the wireless thermostat for us was a challenging product. The reason for this is that it doesn't actually need any batteries. So in the middle, you can see the black spot. This is a solar panel, which is tuned to get the energy from the indoor light. But essentially, this wireless thermostat, it has an e-ink display. People can adjust the target temperature from there. They can, it can also measure temperature, humidity, lux, and motion as well. But the data that you see on the wireless thermostat, maybe later you want to send it to a wiki or maybe to something else, and I'm going to explain a little bit later, especially about relays. Then we have the fan call thermostat. So I personally call this thermostat the hotel thermostat, because in most hotels you always have this thermostat on the wall, which allows you to change the temperature and adjust the fan speed. So if you have such a thermostat, which is wired, but you can replace it with the FCT, with the fan call thermostat by us. And you can imagine, for, let's say, a hotel, if they want to control all the rooms with their current thermostats, the old ones, they have to send somebody to the room, right? If they want to update to, let's say, a BACnet or Modbus thermostat, it's a huge project, as Mario said. They have to put cables in the walls, and it's a construction site. But I think this is where LoRaWAN shines, because without any additional cabling, just switching the cables that are already sticking out of the wall from the previous thermostats, just wire them into the fan call thermostat, and then you have also the radio communication, which allows you to control it and monitor all the rooms from distance. Then the second part of our portfolio, it's about water control and damage prevention. Here we have 2 products. The first one, it's a simple flood sensor, which whenever there is water or any conductive liquid below it, it sends a signal. And it can alarm you if you wish. You can maybe send an SMS to somebody. But when you also install the T-valve, it becomes even nicer, because the T-valve, it's a water shut-off valve. So it means that it can shut off or turn on the water from distance. So if the flood sensor sends a signal, then the T-valve can close the water and minimize the damages from floods. The third category is the air quality and CO2 monitoring, where we have a simple CO2 sensor. It measures CO2 with NDIR CO2 sensor, which gives you accurate readings. It has two AA batteries. It has a temperature, humidity sensor. It also has an acoustic alarm and also like a traffic light. You can push a button and you can see like, is it green level, yellow, or red? We have an updated version of this one, which also includes the e-ink display and again a solar, because um, we want to get away from batteries slowly. But again, this one, same as wireless thermostat, it has the option if you wish to add batteries, but in most cases you don't even need them if you're not living in the Scandinavian countries. Essentially, if you're living in Germany, you're gonna be fine because you get enough sunlight. Then we have the CO2 display light, which is a smaller version of the CO2 display. And this one does not have any option for batteries. We did this later because we realized we have enough sunlight. So it's very similar, but it just lacks the motion sensor. And then the automation devices, we have one very simple open and close sensor. So you can put it on a door or a window. It reports temperature as well. It has a small button. I mean, we've done the devices in a way so you can kind of customize the functionality further. But essentially, if you open a window, it's going to send a signal. We have a multi-purpose button, which when you click it, you get a message, and it's up to you what you do. In our office, when we click it, there's an email being sent to the water delivery company. Yeah, many applications. We also use it with actually the two products that we're going to talk about today. But we use it in the office when you click the button. We have a bunch of buttons. But when you click a button, it turns on the light. If you click it twice, it turns off a light. Then we have the two products that I'm not going to talk about now, but a little bit later. The way we work is we either sell only the hardware solutions, the hardware products essentially, and people integrate them into their own systems. We have documented everything pretty well. Or we can help you with hardware and software solution. So for the software, we have, as Mario said, you need a network server. We don't offer the network server, but we offer the application server, which is essentially only for our products. You cannot control any other brand's products there, but we have optimized the experience there to be good for our products. And the way we work on the market is first in key geographies like Germany, for example, we have distributors who are handling all the commercial aspects on this geography for us, like end-to-end. We also partner with utilities, utility service providers, telecoms. We have a few telecoms, and also facility managers. The third category is the energy efficiency companies or the energy advisors as well. So this is a really interesting segment because essentially those companies, they make their profit out of the savings that they generate for their customers. So we work really well with those partners because our products are unlocking, easy 30 to 40% savings. And then last but not least, we have the building automation integrators and also the SaaS providers. I'm not going to talk about those, but also interesting market where they have the option either to put cables, which is expensive and very time consuming, or to use some wireless, which currently the wireless protocol for such applications have, LoRaWAN has been the answer for a few years now. And for 10 years, we accumulated quite a nice customer base. You can see some of the case studies on the website. I'm not going to go through those, but I think what we see in recent years is that first people, they want to save energy, but they also want the ESG data. So they can, with the requirement to post your CO2 footprint data and to create reports, you need some data to create those reports. So if you have let's say the electricity consumption or the heating consumption, this is one of the things. Then the second thing why I think people choose us is, okay, first we're in Europe, we manufacture here locally, that's one. But the second one is that we have a very long time of the battery life. And we have a battery life calculator on the website where you can see how many years you can get out of the device, but we internally are aiming to always achieve at least 10 years for every product. And something that we invest quite a lot in is the reliability and quality, because with over 500,000 devices out there, of course, they have to be high quality and very reliable. So now we have the ISO 9001 and ISO 14001. The 9001, it's about general quality management, and the 14001, it's more about environmental management. But we always execute projects with, and products with install and forget mindset. We try to do it from the, very beginning, from the design stage. And we are not the cheapest on the market, and there is a reason for that, because you get the quality. And, we've heard this too many times, but if you choose cheap hardware, it's most probable that you're going to end up with a very expensive project at the end. But something that also sets us apart is the firmware updates over the air. So it allows you to upgrade the software running on the device without visiting the site. You just do it from through LoRaWAN. A few clicks, you can see the progress. It takes a few hours on splitting factor 7, but it's future-proof because we're developing new features. Sometimes we're fixing bugs, but we can install, and our partners can install devices very confidently because they know if we update something, they don't even have to send somebody there. And something we do for all the products is accelerated live testing and accelerated stress testing, meaning that we're essentially simulating many years of usage of every product that we make, under stress conditions. So it might be swinging the temperature from extremely high to extremely low, swinging the humidity from very high to very low. But we kind of, approach IoT as rocket engineering. So we're trying to test the limits of our products, conduct as many experiments as it makes sense, and just learn more. I'm gonna be quicker around those slides, but essentially we're very big on ESG as well. It comes from our DNA, because the products that you see, we do them with the main goal of saving energy. But as I said, we had the 9001, we had the 14001. Now we have 27001 ISO, which is about information security. But next year we have a few more things that are around ESG. I'm not going to disclose, but we're moving more and more in this direction, kind of trying to also empower our partners to complete their ESG reports. And as I said, we have more than 500,000 devices out there, and we have a lot of successful case studies, but I'm just going to walk through a few in Germany. This is, Plaza Hotels in Castel, in Heilbronn. But 31% savings with Wiki, which it's quite nice for installation of a few minutes per device. We have one office in Verden, where we had 100 plus devices installed, and again, the 30% savings. This one was actually together with an application server company called DataCake, amazing in visualizing data and combining data from many devices. And here we have a hospital which, actually had reported savings of 35%, a very big hospital. Where they don't only get the benefit of controlling the devices, but also monitoring. Prior to this, they had no idea what was the temperature in any of those rooms. But now to the topic. After the introduction is done, we are launching 2 new devices, and they're very small. I'm going to show them on the camera. Hopefully you see them. But if I have to compare it with my AirPods, you can see how big they are. So those 2 devices are essentially relays, switches. One of them is called 16 amps switch and power meter, meaning it has an electricity meter inside. And the second one is called 16 amps dry switch because it's a dry switch. It doesn't have the power meter inside, but it unlocks some interesting cases of control. The power supply to both is either AC, 110 to 240 volts AC, or you can power them with DC as well, which is 24 to 30 volts. The max switching current for both is 16 amps for AC and 10 amps for DC. And the max switching power, it's almost 4 kilowatts for AC and just 300 watts for DC. Both of them, as I said, have firmware updates over the air. So if we launch a new firmware, if we add some features, you can get the benefit with just a few clicks. No need to send somebody. The ASPM, which is the gray one, it also reports electricity meter. So in kilowatt hours, it reports the voltage, the current, and the power of what is being controlled. And the relay inside both, it's a high quality relay. It is UL&Q certified. Same goes, almost the same goes for the terminals. So the terminals as well, they're UL and VDE certified. But I mean, we invested high quality components into both. And the electricity meter of the 16 ASPM, it is as accurate as a meter you get from your utility company, but we couldn't certify it because one of the requirements for MID certification is to have a display, and we couldn't fit a display inside. But last point, it's about protections. So both of them have a temperature sensor near the terminals. So if we see that, let's say you have used the wrong conductor, or the installer hasn't quite screwed the terminal, there might be some increased resistance and increased temperature. So we're gonna catch it, and we can notify you and stop the device. I mean the appliance, but also the 16 ASPM, which features a live switch. It also have over voltage, over power, and over current protection as well. And here is the diagram. It's really easy. Here, those two are the power supply. This is for the 16 ASPM, but you power the device through those two here. It goes through the electricity meter, and then you have the relay. And then when the relay is closed, the L comes from here. And we have put another N. So those two N are the same. It's just for easier wiring, less viral connections. Yeah, so if you get, let's say, a heater, you can literally cut the heater cable in two, place the two cables into the device, and that's it. No quick connections. And here we have it a little bit different. As you can see, the N and L are separate, and the relay essentially bridges between I and O, as indicated here in the picture too. But just to go over the differences, first, the 16 ASPM, it has wet contacts, so switched live, and the 16 ADS has dry contacts, so it's potential free. Second, both of them have the same size. Both of them have volta. The 16 ASPM, this one also has electricity meter and over current, over voltage, and over power protection. And the 16 ADS only has overheating protection and no electricity meter. But I think what is quite nice about both is also the power supply, because if you wish, you can power the device with DC voltage, and then you can control AC voltage or vice versa. So, I mean, why we did the devices, honestly, the main reason was controlling electrical space heaters, like here on the left. This was the main reason, because we have a lot of partners saying, well, this building doesn't have radiators. Like for Vicky, it has electric radiators, so we had to come up with something. But thanks to the electricity meter in the 16 ASPM, we have actually equipped the whole office with 16 ASPMs. And in this case, we're not so much interested in control, but more about monitoring. Because of the electricity meter, we get the data, we can compare with previous periods, and I'm going to show you some of the data later. But another application is like underfloor heating. It can be, a hydronic underfloor heating where you can control the valves that are sitting on the, they're like electric valves sitting on, the manifold controlling heat circuit. So if you wish, you can control it with both products, really, because here maybe you don't care about the consumption of a small valve. But it can be electric heating as well, which is very popular in the Scandinavian countries, where it's not hydronic, but it's literally resistive parts in the floor heating up. And in this case, the 16 ASPM has the advantage because you can also get the consumption. But essentially anything that is on and off, you can control it. You can control a space water heater. Let's say at home I have 80 liters water heater, and now I know how much does one shower exactly cost. Not that it matters so much, but it's, on a scale, in student accommodation, this kind of things really matter. But also ventilation you can control. The use case we have with electric space heaters is that you can put the 16 ASPM in the wall, but you can also put a wireless thermostat, somewhere in the room, and you can adjust the target temperature from the wireless thermostat, and it's going to communicate either through LoRaWAN, actually both through LoRaWAN, but also directly through device-to-device communication to this device. So in some cases, you don't really need a running LoRaWAN network, because now it's not yet launched, but soon we're gonna announce the device-to-device communication. As I said, we're committed to having our protocol open to document things well, and those below are some of the application servers that have already implemented those devices. But also talking about integration into building management systems. This is valid for those devices, but for all LoRaWAN devices, almost all of them out there. Nowadays, there are a few providers that allow you to kind of translate the LoRaWAN signal to Modbus, BACnet, or just to MQTT. Nowadays, there's also one which offers KNX, for example, which is also quite interesting. But for you or for your installers, if they're taught how to install Modbus devices, they know the tools, they know the process, it's going to be easier for them because they're going to see those relays or those LoRaWAN devices as native Modbus or BACnet devices. So they're going to be able to use all of their tools that they have already. And I feel obliged to say a few things about the installation. This is directly from the instructions, but first, make sure the breaker is off. Do not touch live wires. Second, it's important that you choose the conductor properly. We advise those devices must be installed by a certified electrician. This is our advice, because certified electricians, they know about all those stuff. But yeah, if you want to control a very big water heater with a very thin cable, obviously it's not going to go well. So you have to size the conductor well. The terminals, although they house up to 4 squared millimeters of cable, do not put two cables in one terminal. And when you turn on the device, first there is an LED here, and it shows you if it's connected to the LoRaWAN network or not. If you click it twice, like this, you can switch the relay state. But the installation, it's, again, we're trying for install and forget. You put it there, you see quickly if it's connected or not, and then you continue with the next one. I'm not going to go over this because we're a little bit over time. Maybe, I'm not quite sure, but I feel like it. But I wanted to show you a few graphs. Those are from the office. And now I'm not, oh, there, now I remember. This device, I'm going to show you a few, is actually controlling the sign we have on top of the building, our logo. But we have made a schedule where from 7 o'clock in the morning until 5:30 in the evening, it's off, and then during the night it's on. But here we can see what is the energy accumulated, and you can see the green line, it increases just when the blue region is active, so it means that the relay is on. And then when the relay is off, obviously the accumulated energy doesn't increase. The red line, it's the external temperature, and this is an interesting installation, not really up to code, but we wanted to stress test the device. But here are all the readings you can see the current, the power, the voltage all the time, and you can see how the voltage actually slightly differs. This is another device which is installed into an outlet in the office. And what we see interesting here is that we saw that every morning when we open Windows, essentially there's draft coming out of the outlets and going outside the window, but we could see this because of the temperature sensor, because it just goes lower every day at the same time. So interesting what type of data you can see, not only control and monitor, but what else you can see with those devices. And this is a good example. This is a room with some hardware engineers inside. So here in those valleys, I know that they've been in lunch break, and I can pretty clearly see when they stop their computers every day, and yeah, if they are using some of the soldering stations as well. Just interesting how much data you can understand. And this is quite bizarre. It's the last one I'm going to show you, but this is a very challenging. It's the 16 ASPM with again the electricity meter, but this is connected to a fridge, a microwave, and a water dispenser. So you can see the big spikes or the microwave. Yeah, those regions here are the fridge compressor coming on and cooling the fridge, and the small spikes are actually the heater and the compressor of the water dispenser. So it's really interesting, how much you can see. And obviously we did this because we wanted to see how much does the office consume, in general. We're going to fit it into all the manufacturing stations pretty soon and get an exact CO2 estimation of how much energy does it take to, produce one device. But I just wanted to show you some, additional data, not just talk about the devices. And I think with this, I'm done. So maybe we can go back to Marius as well and start a Q&A session.
Well, thank you very much for your insights. Yeah, as you said, it's always really interesting to see what is happening, and also to see some data you haven't been expecting before, like to see the opening of the window with the power sensor, which has the temperature as well inside. So yeah, I think now we've time for a few questions if you have some.
Yeah, maybe while we wait for some questions, I can also add that the both devices are running in LoRaWAN Class C. So Class C means that the device is listening all the time. So the latency between you sending a command to the relay and the relay actually opening or closing, it's in a matter of milliseconds. Again, it depends on the spreading factor. But essentially, unlike the battery power devices or solar power devices, those devices, they can receive commands all the time. And a battery power device using Class A, usually it can receive a command only when it sends some data. But those ones that you can control them all the time if you wish. Yeah. And I mean, there are some other bizarre use cases that we have heard of now. Not going to go into too much detail, but I think we're also slowly getting outside the building, although we want to stay inside the building as a company because we feel like this is where we can make a difference. But we know we have some customers already because those have been launched for a few months now. But we have some customers also installing it on lights, street lights. Because 16 amps, it's huge. And the reason why we did the 16 amps was basically this is the regulation in most EU countries. The outlet itself, it should be 16 amps. So we said, okay, let's cover kind of the government minimum of what is the requirement for an outlet and then go from there. But if you wish to control something that is, let's say, 60 or 100 amps, you can use a contactor after. You're going to lose the capability to measure the electricity. But I mean, if you just want to control a big machine, you can do it.
We do have a first question here, and it is, do you have an integration to a hotel PMS software? Maybe from before you answer something, my general answer would be, since it's all LoRaWAN, you do not necessarily have to have a specific integration into software. So you can integrate data coming from LoRaWAN for sure into almost any application. But maybe Lubo, you want to say a few more words?
Yeah, I mean, once you get the data, you can integrate with everything. PMS is one of it. We have some partners, like for example, Better Space from Germany. that are really in the hotel industry, and they have integrated the relay, but they have a bunch of integration with different PMS. So our software, we don't have an integration with any property management system, but maybe some of our partners have. Our role in the ecosystem is to essentially enable others to build their products and build their solutions. Yeah.
So yeah, maybe if you want to integrate the data into a specific kind of software, your own kind of software, I don't know the background right now. Yeah, let's just get in touch, and I'm sure we can help. So it's yeah, basically LoRaWAN is an open world, and the data can be used in any kind of third-party application.
Yeah, that's the best thing about LoRaWAN. One of the best things, but yeah. Let's see.
Well, otherwise I'm gonna use the time for some let's say different news. So the next event that is upcoming will be the eWorld in Essen. Big fair for basically everything around energy. So I'm quite sure many of you might know it. We'll be there exhibiting again. So yeah, if you come by the eWorld, make sure to drop by our booth. So would be great to see some of you in person, have a coffee. Yeah, it is also a good very good platform to discuss. There will be many vendors in the LoRaWAN ecosystem as well. So yeah, it's from the 11th to the 13th of February, by the way.
I guess if you want to also see the relays live, you're gonna
Definitely,
have them at the booth, I guess.
Maybe I should have mentioned that. Yes, we will of course have the relays. So yes. Well, okay. I guess that's it. There's no more questions. Anyway, if somebody has a question afterwards, feel free to contact us directly. And yeah, thanks for watching our webinar. Thanks, Lube, again for doing that together with us. And happy to see some of you next time, maybe in eWorld in Essen or in the next webinar. Thank you so much. Have a nice afternoon and see you soon.